Thank you, and great to be here. I'll, as already said, introduce you to Gas2Feed, and we are initially, that's a protein producer, and we are initially targeting, of course, since we're here, the aquaculture market. But in the longer perspective, I think this can also be used for direct human consumption. So, as we've heard already, there are numerous alternatives for novel feed ingredients. We would like to argue, and most of them will actually be used, I'm sure, but we would like to argue that gas fermentation is one of very few alternatives that can combine very high sustainability credentials with unlimited scaling potential. So how does this process work? And you can see here, and already been mentioned in the introduction, we are also recycling CO2, as Geir just told us. We are using a microbe that can use CO2 as the only carbon source. And then, in contrast to the previous presentation where they use light as energy source, we use hydrogen. And then a little bit of oxygen to boost the metabolism. And so all the main substrates are gases, and these are bubbled into the fermentation reactor, where these organisms that contains also a nitrogen source like ammonia and micronutrients. And so there the microbes will grow, multiply, and thrive. And we can continuously harvest from that, from the reactor tank, and simply dry the product. And the product is ready for use in feed as a dried product with 78% protein. And I said unlimited scaling potential. Well, we can in principle use CO2 from air or water, or preferably to have a more decent economy, have a point source of CO2. But in principle, we like to say that give me an electric plug and we can give you as much protein as you like. So, we have currently a pilot reactor, decent-sized pilot reactor. It's located in Stavanger in the facilities of Norse. It's of 2,000 liter. It can produce up to 16 tons per year, which we can use then for feeding trials. But as you can see from this close-up, this is also a sophisticated research instrument. So we can, with all these valves and sensors, so we can optimize the process. And I already mentioned the protein content is very high and is fully comparable to fish meal when it comes to the amino acid composition. It contains all the essential amino acids and so forth. And this is also proven and demonstrated in feeding trials where our experimental diet with 10% blend of our product is fully comparable when it comes to the growth rate compared to the commercial feed control. Now, these organisms have been known for, 3 decades or more in the scientific literature. They were even proposed as a food source for space missions to Mars. But industrialization has been slow. And I think the main reason for that is a lack of scalable reactor technology. And that is what we can offer. I think we can contribute here. We have a proprietary reactor design that, first of all, can operate safely at scale. This is important because we operate here with a mixture of hydrogen and oxygen, and chemists in the room would know that that is a rather volatile gas mix. But we can run this safely. It's also a very simple design, so that it has benefits for CapEx and is highly efficient reactor design or reactor performance, because we can here increase the oxygen concentration in a safe manner. So we hope that our first commercial demo will be at this location, that's Averøy, just south of Kristiansund. And as you can see, this is a fully regulated, prepared industry greenfield, so it's a very nice place. What's important for us is that we here find all the resources we need for production at scale. So our CO2 source will be a point source from a partner company called Bio3. They will present tomorrow down at Spectrum. And there they plan also to produce protein, but microbially with a filamentous fungi. So it's a well-known established technology. They will import molasses, so there's a sugar-based production. And they are more or less ready to start building their first factory at quite large scale, first 30 kiloton at the first step. The important thing is that when you do sugar fermentation, you produce 1 kilogram of CO2, green CO2 of course, for every kilogram of biomass you produce. So from that 30,000 kiloton of CO2 protein, we can convert this into the CO2 into 15,000 tons of our protein, so utilizing all the carbon in the system. For this, of course, we need hydrogen and oxygen, and this we can get by electrolysis. We have a partner for that. I don't want to disclose that now, but we have also all the power we need available at the site. So at full expansion here, we could envision that Bio3 and Gas2Feed together could produce 150 tons of concentrated protein, and obviously that is a large, a decent project size. It could produce up to a third of the national ambition that has been mentioned here in the societal mission by 2034. Now, this societal mission is, to a large extent, I understand, driven by the desire to have a more sustainable feed. And then it's important to take into account that sustainability is not only climate, it's actually a trade-off between different sustainability objectives like climate action, biodiversity protection, and food security and so forth. What's important message from us is that we tick off all the boxes here. So if we look at climate action, we consume all the CO2 here. So, and if you use only renewable power, the CO2 footprint is 0. And if you look at biodiversity, you can imagine these numbers here as benefits. So if we could, from our project at Marvik, we would save up to 250 square kilometers of soy production or replace 220,000 tons of wild catch for fish meal. Now, obviously, there are other benefits beyond sustainability here, and one of them is nutritional quality. That's important because it affects also the economy of projects. And I'd like to explain this potential scenario here, just to explain the relationship between nutritional quality and economy. So here we envision that we will sell our product at $3 per kilo, so more than double soy, okay? When you use the conventional software for calculating energy versus economy, they use in feed recipes, and we put in our nutritional value, we see that we can replace half of the soy, so 10% of the total ingredient, without any increase in the price, despite we sell our product at $3. Fish meal, there's a slight increase, and that's when you do the more detailed analysis, you see that it's actually because you had to replenish some of the oil that you find in the fish meal. So the key message is that even if we sell at $3 per kilo, we can replace soy without increase in price and create a very decent economy for our project. Then another important part of this is supply security. We've heard about this. There's a lot of, the fish meal is stagnant, but still it's there. So we had to take into account the potential growth and so on. Another point is that with climate risk, that can affect both soy production, for instance, with drought, or fish meal production with El Niño effects and affecting quotas of anchovy and so on. Again, Gas2Feed can produce protein without climate risk. We are not affected by weather or climate conditions at all. Finally, health effects. Well, we know for other microbial proteins that there are health benefits, but this we can't really document now. That needs long-term testing. And therefore, my message to any politicians in the room, please continue with research licenses that are very important in this respect, and also make sure that they are tailor-made for food feed testing. Now, finally, even if the politicians say, okay, we have this societal mission, let us help stimulate the market. That would be great, but in the long run, of course, any novel ingredient must compete and be able to live on its own without subsidies. And so we need to appeal to the market, to the end user, to the consumer, and ask, okay, but then we need also to enable the consumer to make, informed choices, right? So we probably should have brands that will visualize the added value. We're trying this in a very modest fashion, though. We are a small entity, but we do this with our sister company, Ecofish Circle. They have a RAS technology, very similar to OptiRAS, we heard earlier today, where they have low mortality and low disease burden and so on. So basically, happy fish. And then we add our sustainable protein to this mix and claim that we will have a high-end premium product, and hopefully that will be recognized, this added value, by the consumers and the retailers. So finally, just to summarize, I hope I've convinced you that we, first of all, have a product that is highly nutritious, it's sustainable, and it can be scaled. And then we also have a product that is unaffected by climate risk. But anyway, and that goes not only for us, but for all novel feed ingredients, there is a market risk. We have to recognize that. And therefore, it's very important to have a dialogue and make the end user aware of what's going on and the benefits. So thank you for your attention.